So welcome again to Back Garden Bushcraft. Today we are going to look at some of the elements required for the Scouting Navigator badges levels 2 to 4. These are elements around map reading and navigation. So one of the important features with all maps that you need to have and need to know are the key and the scales. So on the bottom of the sheet you have the scale of the map, which is in both kilometers and miles. This allows you to navigate effectively and understand your distances. Another important bit here is the key to the map, so that you know that when the symbols appear on the map, you can use the key at the bottom to identify what the various features are. To assist you in navigating, we also have the variation. So the map, there are 3 norths on this map. You have the grid north, which is marked by the vertical blue lines. True north, which for these Ordnance Survey maps is always slightly to the right of grid north. And then you have magnetic north, which actually moves slowly over time. Now on this map, which was printed in 2016, magnetic north is between 58 and 56 minutes west of grid north. However, each year it gradually moves east at the rate of 10 minutes per year. So it is currently moving closer and closer to grid north, and eventually it will end up on the east of grid north, moving closer to the true north. So for the navigation, maps come in a variety of scales, from quite small scale maps, which allow you to cover a large area, with increasingly larger scales, which give you a greater level of detail. So what we'll do is we'll just have a quick look at the maps to show you how much detail that they provide. So we start off with this road atlas here. So this map is a scale of 1 to 150,000. The 2 grid lines here are 10 kilometers apart, and from the image on the map you can see that the level of detail on the map is actually quite limited. What it does mark are all of the main roads, and for a road atlas where you're navigating by fixed road networks, the level of detail off of the roads does not need to be great. Okay, to get more detail we need to change the scale of the maps. Here we have the Ordnance Survey Land Ranger series. There's 204 of these maps that cover the whole of the UK. We have the Land Ranger 161, which covers the Abergavenny Black Mountains area, which is our local area. And when we have a look at this now, we can see that we have far more detail on this map. The grid lines now are 1 kilometer apart. So it allows us to see far more detail of the same area that we was looking at on the other map. You're starting to see woods, hills, features of interest. You can still see all the roads, you can see the rivers, other watercourses, and it allows for far better navigation when you move away from the main routes. Okay, to get even more detail, we can move up to the Ordnance Survey Outdoor Leisure or Explorer maps. These have a scale of 1 to 25,000, so they show far more detail than the Land Ranger series. And if I just open it up, to the correct page, we can see now on here grid lines again. These are still 1 kilometre apart, but there's twice the distance compared to the Land Ranger series. Again, it brings in far more detail. You've got much more information on there. Smaller areas of woodland, different terrain features, better contour lines, and far more detail in built-up areas. For more convenience, you can also get these small 1 to 16,000 scale maps, which cover very small areas. The beauty of these is that they cover a small area. They're a small map, so it allows you to carry them far more conveniently. The big Outdoor Leisure series maps are really good if you're going on a long trek because they cover the whole of the journey, but for smaller local hikes, a map like this, which has a map on 2 sides with a weather resistant coating to stop the moisture from affecting it, is a useful map to carry. It's taken directly from the Outdoor Leisure series, so even though the grid line still covers a distance of 1 kilometre, you get a bigger gap. The level of detail is not much greater than the Outdoor Leisure series because that's what it's taken directly from, but it's a far more convenient map. It allows you to get greater separation between the information you're looking for. To be able to navigate and find our way with a map, we need to know how to orientate the map to north so we can know which way we're facing. The lines on the compass, the blue lines running top to bottom of the page, are your grid north lines. So to orientate the compass to north, or map to north using a compass, we can place the edge of your compass against the north line, and because we know at the moment that grid north and magnetic north are within a couple of minutes of each other on the compass, it's negligible. So we'll turn then the map until the compass needle points to north, and that way the map is also pointing to north. You can also do this when you're out and about if you know where you are on the map, and you can also then identify a key feature from the map to find your way back. So if we was down here by the Llanwenneth Church, and we know that from there we will be able to see the top of the Sugarloaf. So we could stand there, and if we turn and face the map so that we look straight through this point of the map to the Sugarloaf, which will be behind us. We've also then orientated the map north to view. Okay, one of the key tasks we're using any map is being able to locate the features on a map and identify and pass on that information to someone else. So to do that, we use grid references. As we've already seen, the map is divided up into these blue squares, which you can then subdivide up into smaller squares. If we was just to give a 4-digit grid reference, so that's 2 digits from the eastings and 2 digits from your northings, that would only locate us to a 1 kilometre square. Now, if you're trying to find someone in that square, especially if it's dark, it'll be very difficult. We need to be able to narrow that down a lot further. So if we take the little triangle there, which is the trig point at the top of the Sugarloaf, we can at the moment say, if we look along here, that the eastings are 27, which takes us to this edge of the square, and then the northing is 18, which takes it to this edge of the square. Now, for further accuracy, we could take this in, so that will give us a 4-digit grid reference of 2718. We can further improve that by estimating the distance on these. So we could say, looking at this, this is somewhere between 2 and 3 into this. So you break this up into 10. So we take that as 5. And then we go 1, 2, 3, 4, 5. So that makes it somewhere about 2. So that would be 2, 7, 2. And then if we did the same going upwards, we're then going up to 8. So that would be 188. So the 6-figure grid reference for the trig point at the top with the Sugarloaf would be 272188. Now this is done by a rough estimation. To make it more accurate, you can purchase clear plastic scales, and for some of the compasses you will have these on there. These are called Roma scales. So you have your ordinary linear scales here for different scales, the 1 to 50,000, the 1 to 25,000. Conversion tables. We also have Roma scales for 1 to 50,000, 1 to 63,360, and to 1 to 25,000, which is the scale we're using on this current map. So to use a Roma scale, you put the corner there onto the target, so that's there. And we can now read off with more accuracy from here. So we have 27, that's the 2, that's the 3. So we could even go 273, which gives you a 6-digit, or actually 2728, which would give you a 4-digit along there. And then going on the norths, we have, it is 1879. And that narrows you down from being into a 1 kilometre square into a square that is probably less than 100 metres by 100 metres, and if you go as far as a 8-digit grid reference, that's a 10 metre by 10 metre square. If you're using a GPS for your navigation, they even now go down to as accurate as a 10-digit grid reference, so almost to within a metre of your location. One of the key features of the maps used for walking are the contour lines. They allow you to get an idea of the terrain, the shapes of the hills, the valleys that you are walking along, and also there may be some key features like cliffs and things that you will need to avoid. By understanding the contours, you will be able to read the map and determine what your route ahead looks like. And to demonstrate this and have a look at the map, we're going to use a couple of features that all of you should recognise when you look at them. And the first one is the blorange, and the second one will be the sugarloaf. So on here we have the contour lines. You have the pale orange lines, which are in 10-metre graduations, and every 50 there's a slightly stronger line which gives you the 50-metre graduation, makes it easier to read. The further away the lines are from each other, the flatter the terrain. So very narrow lines, or very narrow gaps, means you've got a really steep climb. So the bit we're looking at here is the front edge of the blorange, which, as we all know, climbs up really steeply to start with and then gradually flattens out onto the top. So that gives you a sort of sweeping, a steep face, and then more of a gentle slope once you hit the top of the hill. If I just flip over now to show you the sugarloaf, and this is slightly different in that, as we're all aware, the start to the walk to the sugarloaf is actually flatter, and it gets steeper and steeper the closer you get to the top. An important factor to remember when you're looking at contour lines is if all the contour lines suddenly merge together, you've got a vertical face. Now these are normally marked on here as a clip face, but when they come very close together, you often have a very steep face to a hill, which makes it difficult to walk and almost impossible to go up and down. Now that we know how to get the map orientated to north, we need to know how to navigate on the map. So you can use the map to set a bearing on your compass to give you a compass direction to where you want to walk to. So if on the map we wanted to walk from the Blorange car park to the trig point at the cairn, we could follow the footpath up. If no path existed, we wanted to walk it on a compass bearing, what we'll do is we will take the compass and lay the side of the compass along the line we wish to walk. We then rotate the compass dial within the house, keeping sure that that's on there, to make sure that the lines running within there then lay parallel to the north line on your map. Obviously, if there is any significant deviation between grid and magnetic, you need to take that into account as well. So we could then, from here, look, and to walk then, we will just need to turn the compass and keep the red needle, the north needle of the compass, inside the red northern marking. And by doing that, we can walk a straight line along that bearing. It's useful, however, to find an object within your field of distance that you can see to walk towards, because trying to walk and hold a compass on the bearing is quite difficult. To ensure that you're going the right way, you can also use back bearings to check where you're going. So if we know the bearing to get from the car park to the cairn, the reverse to get back will take you back to the start. And to get your back bearing, you would add 180 degrees to the existing bearing if the bearing you're walking on is less than 180 degrees. If the bearing you're walking on is greater than 180 degrees, you subtract the 180 degrees to get the back bearing. And back bearings can also be used to determine where you are on a map. So using back bearings to locate. Okay, so we're going to have a look at using compass bearings to navigate and to find your location. So if you wish to navigate across an area, like a big open field, big open expanse of grassland, you need to find a fixed point. So you will, from your map, have determined the bearing you need to navigate on. And what we can do is we set the bearing into our compass. So on here, to set the bearing, there's a little line, and that line through there, which is the center line of the compass. If the bearing is 100 degrees, you set the short line through to 100, and what we will then do is we'll then turn around until the north is in the north gateway. We will then look along the line of the compass, and with this is a sighting compass. You have the advantage that you can turn the mirror so that you can see that the needle is in the correct position, and then there's a notch on the top there that you can sight through. And what you want to do is you need to move it, and along that bearing you find an object to look at and fix on, and you ideally want something that's not going to disappear from view as you're walking. The further away it is, the better, because lots of short stops mean that you can increase the error in your navigation. You can use these compasses to a similar way, where you just set your bearing on this one. There is a little red line there where you'd set your bearing. Again, you move it until the needle drops onto the north, and then you look along the lines to see what you can find that will give you your point of vision. We're also able to use bearings to triangulate our position. So if we didn't know where we are, at the moment we're stood in the middle of Castle Meadows, we can take sightings onto various points that will help us locate ourselves. So over this way we can see the Abergavenny clock tower. So what I'm going to do is I'm going to sight on the clock tower through the notch. I'm then going to adjust the ring until the needle is in the north. And then what I can do is look down, read off the bearing there. So that is 19.5 degrees. That gives us one line. We know we're along that line. So I will then turn around. Over there we can see the top of the sugar loaf. So I will take a second sighting of that, and we can turn that round, sight on the sugar loaf, and then we read off, and that is a bearing of 325. That gives us two lines which we can draw on a map, which gives us a cross. However, there is still some variation because there might be some inaccuracy in the bearings. So to improve the accuracy, we take a third, and ideally we want to move round again. So if we swing round, looking over this way, we can see the right hand side of the blowridge as we're looking at it. So I'm going to take a bearing off of the top of the right hand side. So it's not as ideal for accuracy because you don't have a fixed point, but on the map we can probably identify that. And again, I am sighting a third bearing there. Moving it around a little bit. And we have 2, 4, 3. So when we go back, that can be drawn onto the map. The lines will hopefully cross. However, it's quite likely that there will be a small triangle with where the three lines come together, and we can say that our position should be somewhere within that small triangle. It does not give you 100% accuracy, but it will give you accuracy to within a few meters of where you are. You can use the maps and compass bearings to plot a route to avoid some of the more challenging obstacles in your way. You may wish to travel from here all the way across to here, which is a due westerly bearing. However, you have obstacles in your way. You have a steep climb here, a steep drop there, and a lake in the middle. So you would not choose to follow a straight route across. Your options would be to take bearings to find your way up the valley, to cross, and then to drop back. And you would plot your bearings in various stages. So you would go from here to here, plot your bearing, measure it, and you can use either the measures, the scale on the side of your map, or by selecting the correct one on the tape here, which comes on the compass, you are able to actually measure the distance in kilometers. So it's about 0.7 of a kilometer from there to there. That gives you your distance you need to travel. And again, then you would be able to measure your distance all the way up to here, though this will be a fairly obvious point where you would need to cross. If we was on open ground with no roads and we got to this lake at this point here, and we want to travel to that point there to carry our westerly route on, you can't go straight across the lake. So what we need to do is to be able to navigate around the lake to get you back on track. Now, if there's nothing obvious there to mark where you need to be the other side, you have to calculate your position. So you would start from your position here, and you would be heading this way. You would take a right-hand turn from your westerly bearing onto a northerly heading and head north until you think you are past the object. Now, you may not be able to see whether you're past the object or not. So you map your distance. Now, you can do that by counting paces. You then, when you think you're past it, take a right-hand turn to your left. You head back onto your westerly bearing and keep going along. Now, from here, we've actually got a position where we've hit the map, the edge of the lake again. So we then turn again and head north, again counting your paces. We think we're past the top of the lake. We then take our westerly bearing along until we get, as far as we can tell, past the lake. And then we can take another left turn, which will take us back onto a southerly heading, and we count the paces back. Now, this is the paces from there to there plus there to there, and we add those together, which will bring us back down to the point we want to be here. If we hadn't gone far enough and we'd gone down to here, we take those paces into consideration. We then turn on this route and then count the remainder of the paces down. Once you're here, you're then back on your original position to carry through. Other things to consider when route planning are to look for backstops on your route to tell you if you have gone too far. So on a map like this, most of your backstops will be roads. So if you are trying to get to somewhere here, walking from this direction, you know that if you hit that road, you have gone too far. You need to find a backstop that is fairly close to where you want to be. Also, when looking to find a small point, and if we go up here to this information area, and you're coming down off of the hill here, you could take a straight bearing from where you are towards it. So if you're on the trig point and come across there, you take your bearing across here, which will be we're about 65 degrees. However, if that is an isolated spot, and we know this is on the road, so the road automatically becomes our backstop for this. But what we don't know is if we are a couple of degrees out either way, we could end up here or here. And we wouldn't know which way to turn to find that point. So we could end up walking from here all the way up there before we realise, or from there all the way down there. The best option would actually be to set a bearing of 60 degrees, which will bring us down to a point here. So we know that when we hit this, we have to turn south to get to the point we want. And therefore, we will not, even though we walk a little bit further, we know exactly which way we have to go to get to this, rather than walking in totally the wrong direction to get to the point where we need to be.